Alright, well it says MySQL and Apache are both running on the site. If we go to the site, it is back up. Alright, so we have successfully migrated our WordPress blog to the to a larger server. Alright, upgrade is done. So that's how you migrate a server. You didn't get to see any of it, but basically it looked kind of like you basically stop your EC2 box. You can then and start it again after you do that, and it's really easy to do. So if you're running on any servers that are not like virtualized servers, I would definitely run. I definitely do that because we did basically the equivalent of like changing our entire box, and we did it in 10 minutes on stream and all that crap. So why don't we get back to physics and our own little world like we did? So that's what we do. We solve problems because we're engineers. Awesome. So where the hell were we? We were rotating a vector to a direction, and we're going to write a new function here, basically, which is you give it a direction in terms of the y-axis. So rotate vector to direction. Let's do rotate vector to direction, and let's just give it a float, and let's just call y velocity. Well, thank you, Karakan. We're just doing our jobs. And that's one of the things, like, now that I am not working for some big company, I'm no longer on call for like all these server things. So of course, the first thing I did is I was like, Adam, we should totally move your servers around. And then like I'm on call to fix the servers again. And it's right back where I'm comfortable. All right. So basically, if our y velocity is less than 0, we're going to rotate to the left. So we're going to return rotate vector by angle, original, and let's just do -90. And we're going to do an else if y velocity is greater than 0. We'll rotate by 90. I'm okay with a few magic numbers. Otherwise, we're just going to return the original vector. So the other question is, should we pass in? Nah, that's fine. You just do that. So rotate by angle. Good. So rotate vector to direction, and all we have to do is pass in our velocity.y. So we're trying to get rid of extra code here and throw it somewhere else. So if we had to upgrade, if we were originally running on a toaster, what kitchen appliance are we now running on? It's slightly better than not a toaster. Like, these are the different levels of servers. Like, you got we were on a micro, and now we're on a small. But if this is a toaster at the micro level, and we got small, medium, large, extra large, and the Big Mac of servers. So this would be like toaster. Is this your microwave? No, microwaves take power. This is like it's not like a blender either. It'd be like a bigger toaster, it had like the 2 toast slots. Now it's got the 4 toast slots. So I think that's what we're doing. We're just we upgraded from like the Walmart brand to like a Black & Decker toaster. The sandwich maker. I mean, is the sandwich maker a person or an appliance? Why are you getting all pissed off at me? Rotate vector by angle. It's getting pissed off because conversion between enumeration and floating point types are no longer allowed. No longer allowed. Fine. We'll do rotate vector by velocity, and just you can You can get angry with me for that. The best not essential kitchen. Yeah, it was always the joke, basically, when we were in college. And we joke about cracking encryption. It'd be like all of our knowledge was basically like, well, if you had all the washing machines, dishwashers, toasters, and smart refrigerators on the planet trying to crack this SSL cipher, how long would it take? Because I think that was like one of the big denial of service attacks was like the Internet of Things. Because like if you buy like smart light bulbs and like all sorts of other crap and you throw it up around your house, all those things have little microcontrollers in them and they're connected to the internet. And most of them are written by people who really don't give a damn about security. So a lot of those things are very easily compromised. So all of a sudden you've got like 200 million, yeah, 200 million smart light bulbs blowing up your servers. Yeah, this is screwed up. I'm all like not even paying attention anymore. And like, what the hell I'm doing? I need a reset. I need to reset. Yeah, and if nobody's gonna comment on my shirt, I will. This is one of my friends, Ivan's shirts. He's got this studio called Alpaca Spacelab, which I can link that. And he works on some pretty cool indie games and some VR. And he's a good friend. So if you ever feel like checking out his games on, I think they're on like Amazon and the Apple Store and Google Play and all that stuff. He's got some fun games that yeah, he's a nice guy. And who knows, we might even work with him at some point. We'll see. It's he's somebody that we worked with at EA2D, and Adam worked with him as well when he was there. He was a tech artist there, so he's a cool guy if you want to go check somebody out. I don't think he streams anything. We want movement direction vector is what this F vector is. Actually, we already have it, so we can just do this. And he made the t-shirt, and I bought one because I thought it was pretty cool to walk around with an alpaca. Thought it was a cool mascot. Speaking of which, I've been ragging on Adam to go make some more t-shirts. It's like, Adam, we need t-shirts. Then we'll be like legit game developers. Like, he's already got t-shirts for other things, but we need like some Dashkin t-shirts. So we'll see what happens. So when I get to bitch about stuff, maybe you can get some stuff going on. Alright, let's just double check that what the hell I wrote when I wasn't even paying attention to what the hell I was doing actually does what I think it should. Yeah, does he have it on his streaming list today? Because if not, it'll be on, I hope, this weekend. Alright, so this should definitely, we should be, yeah, okay, good. It's doing exactly what it was, which is what it should be doing. I'm gonna grab another energy drink. I'm out of caffeine, so that's a problem. Oh, yeah, Adam put together the wrong dojo logo. He like drew it on a whim, basically. Like I didn't even tell him anything about the backstory of the name. Excuse me. He just kind of came up with that, which was pretty cool. He's like, "This is what I imagined," and I'm like, "That's exactly what I pictured," which is the thank you, ThinkOG, for following. Which is like the two guys there, and I really like the guy on the left, right? Which is just like he looks like a total nerd, at like some dojo with he's got like a little stick and everything else, and he's just like if you were pretending to be like a ninja guy, that's totally what it would look like, which is kind of the point. And it was a joke at Amazon, basically. One of the games that they're working on, they had a whole bunch of like. It was outdoors, and you're, yeah, yeah. Go ahead. What did you think you should? But basically, like we were playtesting this game, and one of the devs, like the game was crashing, it was awful, it was all sorts of screwed up. But that's some of the best times. And what we did was the left guy, Adam. Yeah, that's totally correct. That is exactly what I thought too. I was like, it's perfect. And we're playing this game, and everything was crashing. So the guy's like, "Screw it!" and he spawned in like 100 turkeys into this level, and all these turkeys start fanning out because they're turkeys. And then he's like, "Screw it!" Turkeys, you came to the wrong dojo, and he spawns in 100 wolves, and all these wolves just start eating all the turkeys, and like they're dead turkeys going everywhere. And then he's like, "Oh shit, wolves, you came to the wrong dojo," and he spawns in 100 bears. All the bears start taking out the turkeys. and then he's like, "Oh, bears, you came to the wrong dojo," and he spawns in like 5,000 turkeys that just start fighting with all the bears. And then he's like, "Oh, turkeys, you came to the wrong dojo," and he spawns in like all of the horrible monsters, like 100 of these awful monsters that just like destroy everything. The server is like grinds to a halt because there's like 10,000 of these enemies all just like massacring the hell out of each other, and like the physics and everything's all broken. So this is like a nice lush landscape with like a pond and everything. Like the turkeys are in the pond, but because it's like not finished, the turkeys are under the water, like fighting underwater with the bears and the wolves and the horrible monsters. And it was just like, yeah, man, those turkeys came to the wrong dojo. And then I quit Amazon, and I was like, that's my company name. So that's kind of how things go. That's what's awesome about the game industry is like stupid crap like that happens. Like you have a failed playtest and everything is messed up, and then somebody makes it awesome. So where the hell were we? We were trying to clean up some of these functions. Yes, the stories. Yeah. Well, we'll see if we can do some more story time after we get some work done. Alright, so we're sweeping our component down, and we're getting our surface normal and our impact points. I think what I want to do is I want to make like a shortcut function which returns a lot of these things, but not yet. Yeah, I couldn't make them up. That's true. I could not make them up if I tried. That's why it's really awesome. Like, if you have a studio that has a bunch of younger devs in it, you get a lot of that really good energy going on. You don't always get that if you're like a bunch of senior crotchety dudes, sitting around being important all the time. So I kind of like working with a lot more younger guys on projects. I mean, Adam's all right though. He's not old. You know, a lot of people they get mentally old, even if they're not old, and it's just they're not fun to work with. All right, so we got our impact point, we got our start position, our movement direction, our movement distance, and basically, if we did not hit anything with our sweep, so move along the surface. So what we want to do is this right here, we should cut and paste all of this crap out and return move. This is update locomotion on ground on surface, and we'll see what this method needs to take. Update locomotion on ground on surface, and we need to pass in delta t at least, right? And we're also going to be returning a delta t. So float goes there. We do need this float t. He's 5 years old mentally. Wow. Yeah, we had one guy at Amazon. His son helped him out, mainly in terms of getting him Grumpy Cat themed everything. He was a help. It's pretty funny. Like he was a pretty quiet dude, but like he brought his son in a few times. It was really funny because he was just sitting there playing Minecraft like the whole day, just on his computer next to all these guys who were working on stuff. And like, because we're all game devs, right? We're just like getting distracted watching this kid play Minecraft. Because you're like, you're working on some code or something, and you're just like, oh man, he's running away from those zombies. No, man, you need to get some food. Like, go bake some bread, man. Oh no. You have to stop yourself, and you're like, dude, he's 5 years old. You can't be like backseat gaming a 5-year-old. Jesus Christ, what are you doing with your life? His idea is a GTA space type game. That'd be pretty cool. That'd be like if you had Mass Effect, but with a lot more strippers. Should have more of a story. Well, an open world game where you murder everybody can totally have a story. You can go bowling, you can go space bowling. Alright, so we're going to need a movement direction vector. We're going to need a movement distance. So we're going to go ahead and start doing these. It's going to be f vector ref movement dir, and then we're going to have our float movement distance. And we need our start position. So we're going to need f vector start position. We're going to need the components. And as my CS 100 teacher said, if you find yourself with a function that takes more than 5 variables, you probably forgot a few. So we probably forgot a few variables here. So let's see, where are the hits? Hits are right here. Space Invaders. Nice. Gotta start somewhere. Gotta start somewhere. Alright, I think we actually, that might actually have what we need. So we're gonna have kind of this private here, and this is gonna be locomotion, movement functions. Alright, so we need to pass in delta t, start position, movement direction, vector, and our components. Does that please the gods? Let's compile and find out. We will see. You have to fight in the city. That reminds me of like Earth Defense Force, to be honest. I don't know if you've seen Earth Defense Force like 2017, but it's just like a whole bunch of campy amazingness. Function does not take 4 arguments. Oh, hell yes it does. That's... Alright, it takes 5 arguments. I'm an idiot. Alright, you're right. You're right. I need the movement distance. If you've never seen EDF 2017, it's one of the best games ever made. And this image pretty much sums it up. You're this dude, and you fight just swarms of ants and all sorts of crap, and you fight them in the desert, you fight them in cities, everything explodes. These things don't even have like death animations, they just like freeze up and then like bounce around when you blow them up. Every single weapon is a bazooka. It's a pretty solid title. Actually, one of the guys at EA2D we worked with did work on EDF. He was a concept artist for him, and like you might think like the whole thing's a joke, like oh man, you know, all this like campy sci-fi like, you know, ants killing each other and stuff. No, the guy's completely serious about like, no, this is real stuff. And so they had this concept artist there, and they just all they wanted were more pictures of ants. He's like, yeah, I need pictures of ants. It's like, okay, yeah, okay, well, here's like, you know, 100 pictures of ants. And he's like, no, okay, good job. We need another 100 pictures of ants. And it's just always ants. Just all the time. Just too many ants. Too many ants. Alright, impact point is not set. Do we have the surface normal? We need a surface normal, don't we? So surface normal and impact point need to be outside this scope. And we're just kind of moving code around at this point, which is like pushing our food around on our plate. We're just trying to make it look better and be easier to deal with later. Closest distance to floor. Yeah, of course we threw that in there. Alright, so hit distance. So we did not hit anything in our sweep, so move along the surface. Scale is just so large? Yeah. So if you're working in Unreal, are you working in C++ or are you working in blueprints? What sort of stuff are you working on there? It's pretty funny. I can't see any stats on like my channel. Like the stats thing is just broken for Twitch dashboard. So I keep freaking out. I'm like, is this thing actually on? Is this working? They need to reset their databases. All right, let's just make sure that Fatsack's still roaming around. Good. Okay, so we're still moving properly, so we didn't screw anything up when we moved our code around. Alright. So we did not strike any object in our sweep. That's why we are here. We can get rid of some of the debugging our position after the sweep. And so... There are always issues with Twitch. Yes, I am familiar. Yeah, that was always the best. We were working at Amazon, and Amazon bought Twitch, right? So, as part of Amazon Game Studios, we were kind of the closest people to Twitch in Amazon, and there are some stories of dealing with them that I cannot tell. There were some really just hilarious stories that can never see the light of day. So, we're going to find the closest floor below and snap ourselves to it. And I think our snapping to the floor is actually working properly. So, do we actually want to name this function Yeah, we don't need this overlap anymore. That's fine. That was just a test. So this is new position. Where was it? Did we just get rid of new position? Yeah, new position is start position plus. So this really should just be like snap ourselves to the floor. That's what this should be called. So, and we should be passing in our new position to this function. We're basically saying, here's our position, now snap ourselves to the floor, I believe. I believe that's what we want. Blender in 3D and blueprints. Alright, cool. Yeah, that sounds like a pretty awesome project. I'd recommend while you're working on it to get some screenshots and maybe some video of it. It's sometimes very interesting to go back and see like what the game looked like in development, because stuff always looks way different than what you'd expect. So we actually want to pass in our new position, and our new position should be calculated up here. So start position. Yeah, this should just kind of work there. So we go ahead and calculate that, so that's what new position is. Movement direction vector, do we even use this? Yeah, I don't see us using the movement direction vector, so we can get rid of that. Do we use the movement distance? No, we don't use movement distance either, so we can just get rid of that. So really we're just saying, here's our components and all that, in which case we don't really need that. We can just we could just get this every frame. That's probably what we should do. Cached components. We should just grab all the physics components at the start of the frame. That way we don't have to pass this stuff around. So we're going to do it tick movement and get it in the update function. I'm just going to do cached components dot reset. So we'll do it like that. So we'll always have our cached components ready to go. We don't have to pass any of this stuff around. Discover physics state. Maybe we should make a method that's called like cache components. Yeah, that sounds like a better plan. Cache physics components. So if mActor does not equal null pointer, then go ahead and snag them for the physics components. So some of these things, yeah, we could just call cache physics components on, and then we'll have them. So again, we'll hide this down at the bottom of the file because nobody wants to see our dirty laundry. This is part of the update stuff, so we want to throw it in the update. Very good. Alright, tick movement. We'll do that. Alright. So cache physics components at the start of this thing. And again, we want to check our cached component array here. So if we do not have any, then we're just going to call move object because that's a degenerate case. So all those things, cached components, again cached components, again cached components, and again cached components. So instead of update locomotion on ground on surface, we're going to have update snap to floor for this thing. So what it'll do is it'll snap us to the ground, and that way we can reuse this in other functions. We'll be like, oh, well, we're supposed to be snapped to the floor, so let's snap ourselves to the floor, why don't we? And we just say how long it should be able to simulate for, the position that we're in, and we don't even have to pass in the components. We just say, this is the position we're in, this is how long we simulated for, and snaps to the floor, please. Not bad, not bad. And this should be cached components again. And we're basically slowly cleaning up like a whole bunch of spaghetti bullshit code. And hopefully making it more readable and maintainable later, because we finally got, you know, like, okay, we solved one of the problems, which was moving in a direction and staying on the ground. So now let's make it not crap. So it is the weekend. It is, well, it's Friday. Does everybody have awesome weekend plans going on now? Because I certainly do. I'm going to be right here on Twitch making stuff in Visual Studio. And hopefully not fixing the database every 5 seconds when it explodes. Because hopefully it doesn't explode. And who knows? Maybe we can convince Adam to do like maybe a Torchlight dual stream sometime, because I want to play that too. Though I've already played it before. I played it when it came out. Filling in Amazon tax things. Yes, that sounds amazing. That sounds like a great weekend. I'm being completely non-sarcastic. You know, that's like what I envision myself when I retire. I'm just gonna retire, and all I'll be doing is filling out tax forms. Oh, watch me first. Well, thank you. We'll be here hopefully, doing some work, having some fun, telling some stories. I mean, one of the interesting things is, like, I worked at a whole bunch of different companies. Like, I got hired to work at EA, and it was kind of a small studio in EA. It was BioWare San Francisco / EA2D. And then worked at Waystone, which was, it was like the ashes of Maxis, there on the executive floor in EA. And that was more like, it was a larger studio than like EA2D. And then I went off and joined a startup at Molten Games down in San Diego, which was kind of like a 60-person startup that lasted like 11 months before we suddenly ran out of money and everybody had to go home. It's like literally the week before we were hiring people, and then bam, hey, sorry guys, there's no money. We're sorry, y'all have to find jobs. And then working at like a big place with Amazon Game Studios and Amazon, and each of them had very different like things to learn. And I think one of the most valuable is actually working at Amazon, where you learn a whole hell of a lot about cybersecurity and just when you've actually got like, millions of people's credit card numbers and personal information, you act a lot differently as a corporate entity. It's all about like, there's a lot more protectionism and a lot less wild, wild west. Learned a whole lot talking to like the InfoSec and AppSec security guys, which has changed pretty much everything I do with my life. Like, I'm using like random passwords all the time, and I'm using, like password safe technology stuff on all my things, and I constantly berate everyone else and feel smug about myself for doing so. And that really helps my self-esteem because I like to feel good about myself. Alright, so update snap to floor should snap us to the floor. And perhaps we also want to give it a little bit of a... Because we have this up here, we've got our discover physics state, and we want to like set ourselves to being on the floor. Maybe we should be passing in a distance to actually snap to. So like, we'll do like float max distance for snapping to the floor. And that way we can just call the same thing from both of these functions. Sign combinations. I don't know any sign language. Let's see, max distance. Closest distance to floor is greater than physics far enough. After the sweep, we're in the air. Alright, floor stick distance is what we've got. Floor stick distance is this guy. So we are going to move him up here. And do such. Yeah, it was kind of the thing is like when you actually need to go, it wasn't about like the security with the passwords was not about having more secure passwords. It was about being able to change the passwords at any time without a problem. Like basically, it was all about if you change a password, you should just be able to change the password, and it shouldn't be a big deal. So it was all about making sure that you could at any time just be like, there's a new password, because you can leak a password on accident somehow, and if you can just change it instantly, like bam, you're pretty much protected. And then to go a step farther is just like automatically have a system rotate your password for you, and then you don't have to actually remember anything. It just works. Which is how a lot of big companies work. Then you use physical tokens like key fobs and thumbprints and all that sort of stuff for physical security, because physical security is pretty good. Yeah, keeping track of them, yeah. Alright, so we have closest distance, max distance, suggest a new point, and all that stuff. So what we're going to do is we're going to change... Do we have anything in here for like cache components is empty? We do not. So what we're going to do for update discover ground is... I think we can just get rid of this crap and do physics far enough with a snap to the ground. And all we do is update snap to floor. And we're going to pass in, 0.0. And our new position should be our current position. and then we just pass in physics far enough, which is basically a really big number. And we want to also print out our proper position. So is there a get position? Yeah, there's a get position. So we're just going to say set position equals get position. So why are we doing any of this? We should do get position up here, and we should be setting position to get position after this, and then not using set position. Transform set translation to that? No, we should be not dealing with this crap. We should be calling set position right here. Discovering physics location for object with no physics box. Ray trace in the downward direction for our actor. The results are 0. Set position is going to be position. That's should go there. So distance is again something that goes inside of here. So what we want to do for this is we want to do update snap to floor as point, and we're going to give it this G physics far enough. Not a problem. So float delta t, and then we want the f vector, a const f vector, position, and that should do it. We're going to return delta t. And these things are going to come in handy much later, like when we have, you know, this physics code is going to explode because it's going to need a handle if we're flying and if we're in the air and the ground or snap to a wall, and just having these nice little things like, hey, snap this guy to the floor, snap this guy to the floor as a point object. Just that's where we're going to have all of our, that's how we're actually going to control all this garbage without actually going insane in the process. Because not going insane in the process is pretty important for some of this. Good. Collision channel for physics type. Do we actually need this? Yes, this is the group that we have, so ray tracing in that direction. And I believe this, we should do an if check here, because if we don't get anything, we already know. So, yeah, if we didn't get a hit, then we just call set position. Set position, it's just going to be position. Results should be passed in. Alright, that's better. Direction? Yeah, so the direction should be down, so we should just do that. Not a problem. Set position is equal to position. And we call set position there. Not, yeah, that should work. That should work just fine. We don't actually need to call set position if nothing's there, because we should already be in that location. Because that's our current location. Well, maybe it's not passing it in, so it's not guaranteed. Somebody might pass something into us. Maybe be like, we'll snap this to the ground, and then we're just in like a check to see if something else is messed up. And this is going to be our distance. So max distance is going to be this guy. So the distance is going to be this. Well, that's not too hard. Very good. Well, let's make sure we're actually snapping to the floor properly before going on. Because the next thing is going to be, we're going to need to be able to move over stuff. So if we're moving along a surface, and the surface kind of goes like this, we're going to want to sweep test to, in this direction, and kind of put ourselves right here. And then what we're going to want to do is we're going to see if we can kind of bump ourselves up and over this object so that we move right up here. So we're going to do one move, and then we're going to do another move. That's going to be the kind of the next step. So much work just to get Fatsack to move. You'd think he'd be a less ornery fellow. But no. He's had a hard life in Brackenwood, getting abused by just one person, one creature. So just double checking. Trace tag. Dash. So we started on the ground as we should, and it's looking exactly as it should look. Excellent. So snapping to the floor, that's one of our pieces of physics. Now the next one is, so if there is a collision, we need to move as far as possible along the direction of motion. Then we need to move to be on solid ground. So yeah, I guess this is what we're doing. So if we move, there's a lot of different locations. So like if we move, we're going to move as far as possible, and then we need to settle ourselves to solid ground. So we need to move and then snap as far as we can. Alright, so hit distance is greater than physics far enough. Greater than equals, which basically, do we hit something? Otherwise, we struck ground and are unable to move in our sweep direction. So what we want to do is we want to actually move to that location, then we want to snap to the ground, and then we want to then attempt to mantle. So it's going to be, we're going to need the amount of time that it actually we simulated as well. So we need the sub delta t is something we need. We need the f vector new position. And we need to then do snap to floor, and that's going to be like floor snap dt, and we're going to pass in sub delta t there, and we're going to have the new position there, and the floor stick distance is going to be like sub delta t times this thing. But we need to figure out the sub delta t, and the sub delta t is going to be based on the hit distance. We're going to need to get the magnitude of the movement distance. So we're going to do the movement distance. So sub delta t is going to be the distance we move. So hit distance divided by the distance that we move. So movement distance. So we're going to call sub delta t 0.0. We're going to say if movement distance is greater than, 0, then sub delta t equals hit distance divided by movement distance times delta t. So basically we take how far we were able to move of our total move and we multiply that by the time that we're going to simulate. So in this case, if we moved half of our distance and we have simulated for 10 milliseconds, we are going to get 5 milliseconds because we have 5 more milliseconds of movement to do. Well, that's how much we actually moved. We need the inverse of that. So we need extra delta t, which is going to be, we don't actually need that. We're going to be returning our sub delta t is what it sounds like. No, we're not going to return our sub delta t. We are going to actually need this because we need to mantle during this frame, because we passed it off to the next one, we're going to be on the ground and it's not going to work. So we need extra delta t, and that's going to equal the delta t minus sub delta t. So this would be like another 5 milliseconds. So yeah, so that's our floor snap delta t there. Is there any reason for snap to floor to return anything other than the actual delta t? It doesn't look like it, but basically what's going to happen here is we need to know if this was different for some reason. I don't think it's ever going to be different. So it's kind of we'll just say it's always guaranteed that delta t is returned at the end of this function. It's kind of just a shortcut. Which kind of begs the question, why don't we just never have that actually returned so we never get confused? Because the worst thing is when we accidentally change one of these things and we break something totally different. So we're just not going to have that bug when we come to it. We're just not going to return anything from these methods. So that's fine. That's actually good. So floor snap dt doesn't exist. We just have extra delta t, and for extra delta t we're going to attempt to mantle. So we need to figure out how to do that. If movement distance, well, we should probably, instead of doing this, we should do like if movement distance is less than or equal to 0.0, then we just return delta t. It's like, okay, we've simulated our entire time. Because there's no point in the rest of this crap if literally everything is 0. So that's going to be our delta t. We're going to need our new position. Our new position is going to be the well, in this case, this is the position. Our new position is actually going to be the start position plus the movement direction a movement distance is times delta t, so this is going to be sub delta t. That's what it looks like. So that should be our new position. And then we're going to snap to the floor. So update snap to floor